All right, everybody. So if we take a look, and by the way, this is the way I'm going to number things here. This is the DNS review book, exam number 1 and problem number 15. So they gave you a rational function here, y is equal to 2 over 4 minus x, which I took the liberty of just rewriting as 2 times 4 minus x to the negative first. And the question was about what values of x this graph is concave downward on. Concavity is a product of the second derivative, everybody. So went ahead and differentiated y once. Got a 2 right here. Remember here, everybody, that we're taking a negative 1 times the 2 via the power rule to get a coefficient of negative 2 times the same base to the negative second. But then with the chain rule, times the derivative within of negative 1 turns that 2 back to a positive. We need the second derivative now, so the same thing applies. The negative 2 times 2 would have made a negative 4, but the chain rule says we multiply by the derivative within, turning that back to a positive 4 times 4 minus x to the negative third, and here it is rewritten as a fraction. So, with our second derivative, the sign of that second derivative determines concavity. So we look for spots where the second derivative is either going to be 0 or undefined. Well, with a rational function with a constant in the numerator of 4, that second derivative is never going to equal 0. However, it is possible that that second derivative would be undefined anywhere the denominator of your fraction would equal 0. So if we set just the bottom equal to 0, took the cube root of both sides, that just gets us a 4 minus x is equal to 0, and brought that over there to the other side, we get x equals 4. So this would be the one spot where the second derivative is undefined, and we could have a sign change there. So what we went ahead and did then was to make a sign chart from this one value where the second derivative is undefined. And I realized usually we pick test values here. So when you guys were doing this problem, you may have done something like x equals 3 on this side, and then x equals 5 on the other side. That would be perfectly fine. And now we test it. It's a question of concavity, so we put these values into the second derivative. And if we put something less than 4 into this derivative, the second derivative right here, such as 3, 4 minus 3 would be positive, so 4 divided by that positive number would get us a positive second derivative, meaning that our function then would be concave upward anytime that x is less than 4. Putting in any x value greater than 4, such as 5, is going to turn this denominator here negative. 4 minus 5 would be negative 1, cubed would be negative as well. That makes our second derivative less than 0, meaning that we are concave down on this interval anywhere that x is greater than 4. So we do in fact have a point of inflection here because the sign of the second derivative changed, but I wrote that without having read the question carefully enough, and the question was, for what values of x is the graph of y concave downward? And we've got that right here, so this is going to happen for any values of x that are greater than 4, which makes the correct answer to that question B.